The one-to-one property for exponents and logs is a property that you can use if you create on the left side and the right side of the equation, you have the same base, you can set the exponents equal to each other. So if I had 3 to the x equals 3 squared, since I have the same base, I could just set the powers equal to each other and x equals 2. The same thing is true for logs. If you have a log on the left side with the same base and a log on the right side with the same base, you can set what's inside the logs equal to each other, which is where the x equals y comes from. So if I have log base 2 of x equals log base 2 of 4, that just means x equals 4. To solve this exponential equation using the one-to-one property, we must make everything the same base. So we need to change 9 so that it becomes 3 squared. We already have the base of 3 on the other side. Now that both have the same base, you can just set the exponent portion to equal to each other. Using the one-to-one property, we know that 2 equals x plus 1. Now we just solve for x. X equals 1. In this example, we want to make everything have the base of 3 again. On the left side, we already have 3 raised to the 2x plus 1 power. However, on the right side, we need to change 27 to be a power of 3. 3 cubed equals 27. So we can change 27 to be 3 cubed, and then we raise everything to the x plus 4 power. Since 3 cubed is raised to the x plus 4 power, and this is a power, we must multiply. So the left side remains the same, 3 to the 2x plus 1, but the right side becomes 3 to the 3 times x plus 4. We need to distribute the 3, so it becomes 3x plus 12. Now, since they have the same bases and we have a single exponent, we can set the exponent using the one-to-one property equal to each other. So 2x plus 1 equals 3x plus 12. Now we just solve for x. We're going to subtract 2x from both sides. We have 1 equals x plus 12, and then we'll subtract 12 from both sides. X equals negative 11. In order to solve this example, we must rewrite everything as a base of 2. 1/2 as a base of 2 can be rewritten as 2 to the negative 1 power. 8 as a base of 2 can be rewritten as 2 to the 3rd power. We will now go through and rewrite. 1/2 is 2 to the negative 1, all raised to the x power, and 8 is 2 to the 3rd power. Now, since this is up raised to a power, we can multiply. So it becomes 2 to the negative x equals 2 to the 3rd power. Since they have the same base, we can use the one-to-one property to set the exponents equal to each other. So negative x equals 3. We divide by negative 1, x equals negative 3. Now it is your turn to practice. Try these problems on your own. To solve a log equation using the one-to-one property, you must have a log on the left side and a log on the right side that have the same base. With this particular problem, we have two logs that have the same base, but they're both on the left side. So to use the one-to-one property, we must add the natural log of 3 to both sides. We now have the natural log of x equals the natural log of 3. Since they have the same base, the natural log, the base of e, you can take the two log portions and set them equal to each other, which means that x equals 3. With log equations, however, we must check for extraneous solutions. That means we must take our value and plug it back into the original equation. As you recall from our domain exercises, you can't take the log of 0 or a negative number. Since x equals 3 does not make this natural log negative or 0, it works. There is no extraneous solution in this situation. In order to solve this equation, you notice that they both have base 3. And there's a log on the left side and a log on the right side, and there's only one log, which means using the one-to-one property, we can take the two portions inside the log and set them equal to each other. So 2x plus 5 equals x minus 2. Now we'll just solve for x. We'll subtract x from both sides. So I have x plus 5 equals negative 2. And then I'll subtract 5 from both sides. X equals negative 7. Since this is a log equation, we must check for extraneous solutions, which means we need to plug it back into the original equation and see if it makes the log negative. If we plug it into the right side, which is the slightly easier side, we can quickly see that we get log base 3 of negative 7 minus 2, which is log base 3 of negative 9. You can't take the log of a negative number, which means our solution, negative 7, does not work. So it's an extraneous solution, so we have no solution. We see in this example that we have a log base 10 on the left side and a log base 10 on the right side. Remember, if there's no base written and it's log base 10. So we can take what's inside the log and set it equal to each other using the one-to-one property. So 4 minus x equals x plus 1. Now we can solve for x. Add x to both sides. So 4 equals 2x plus 1. We can subtract 1 from both sides. 3 equals 2x. Divide by 2. Divide by 2. X equals 3/2. Since it's a log problem, we have to take the 3/2 and plug it back in to make sure that we don't get a negative log or a 0. So log of 3/2 plus 1 is the log of 5/2. Since this is positive, we know that this value of x works. So our final answer is x equals 3/2. In this example, we notice that there are two logs on the left side and one log on the right side. We can still use the one-to-one property, but we must use our log properties to condense the left side into one log. Since we notice there's a subtraction, we can use the quotient property to turn this into log of 4x divided by 12 plus x equals log of 3. Since we use the quotient property, we now have a log on the left side and a log on the right side. We can take what's inside the log and set it equal to each other. So 4x divided by 12 plus x equals 3. We can solve this equation by multiplying both sides by 12 plus x. On the right side, we'll distribute. So we have 36 plus 3x. And then we'll solve for x by subtracting 3x from both sides. X equals 36. Now, since this is a log problem, we have to make sure that it doesn't make the log negative or 0 anywhere. If we quickly plug it back, 4 times 36 is going to be a very positive number. 12 plus 36 is also positive, and then log 3. So x equals 36 works. Now it's your time to practice. Use the one-to-one property of logs to solve the following equation.